Today I'm going to be talking about next generation concrete pavement surface. You know, when I first heard this name, I thought, man, this is something on like the Star Trek Enterprise or something, you know, next generation. This is awesome. I got to figure out what this is, you know. So let's go through that. What is next generation concrete pavement? If I can. So next generation concrete surface is a term used to describe a longitudinal noise attenuating texture treatment that can be utilized for both new construction and rehabilitation of existing surfaces. So both new and existing. The surface so far is the quietest and smoothest concrete pavement surface measured to date while providing desirable friction characteristics. So I'm going to go through basically the existing tining and what we use currently in the field prior to next generation concrete surface. First, you have your transverse tining and your random transverse tining. These two tinings are used with a rake. They're manually set inside the, or on top of the pavement surface. The depth of these kind of varies because it varies with the person placing the tining. And you also have the astroturf, which is what you see on the bottom left, and the longitudinal grooving. Longitudinal grooving is something that we use on the bridges mainly. So now the question becomes, how did we get to next generation concrete surface? How do we get from this transverse tining or this rake procedure in the field to next generation? So to do this, we focused, or Purdue focused, on the interaction between the tires and the pavement surface. And this interaction is basically where the high levels of noise are coming from. So if you see on the left, we have the transverse tine and the longitudinal tine. On the right, you have a conventional diamond grinding and the next generation on the bottom right. I show some decibel levels between the two and some comparisons you can see on this slide. And I'll get into that a little bit more in depth later on in the presentation. So the tire pavement test apparatus that Purdue used is what you see here. It was developed through research for Purdue's tire pavement test apparatus and is unique in that it allows testing of multiple surfaces under controlled laboratory conditions. Now, in a lab, it's not always the same as what you see in the field. It's a little bit different, but in this controlled instance, they were able to really focus in on how to change the longitudinal grooves, the depth, the width, the variability between them, and to really focus in on what changes the sound and the noise between the surface of the pavement and the tire interaction. So what they found is that the texture in the upward or positive direction is really what creates a loud noise between these interaction of the pavement and the tire. And this is really a really good finding on this interaction. The positive profile of this is the increase in noise, and the texture with high fin land variability produces the high noise levels. Now the fin is what you see on the left, and basically that is the area protruding between the grinding grooves, and the land is the area on top. So the fin is what we basically want to reduce, and we want to create a uniform land on the pavement surface. And that's this slide here. The land area, what you see on the top, it's kind of jagged. Now that jaggedness is the positive fins. That's what you create with the positive fins. The high land variability is what we want to reduce and prevent, and that's what the next generation is the purpose of this. Reducing the macro texture to promote a uniform fin profile will reduce the overall noise level. The texture in the downward or negative direction, which is what the next generation concrete surface is pushing towards, this creates a controlled land profile on top and that negative texture in between the land areas. So I'm going to get a little bit into the construction on the US 290 project. So the 290 project spans from 610 and 290, which is what you see on the right, all the way to the county line, which is Project A on the left. It's 13 active construction projects, approximately $1.3 billion in construction. We're implementing this next generation concrete surface on throughout the 290 project. It's kind of like a beta. So after the contractor places the concrete and places the temporary tining, then we'll go back and perform the next generation concrete surface. Now, the next generation concrete surface is placed with a multi-pass operation, meaning first you have to grind up the existing tining and the pavement surface, and then you go back and place grooves in that surface. Now, a key idea is that the conventional grinding equipment is used for this construction. We really didn't want to try to utilize this on the 290 project if the contractor will have to go out and buy all new equipment, all new grinding products, all new blades. So it's real important, and it was really good that we could use the conventional grinding equipment in order to place the next generation concrete surface. So here's the two-step process that we're shooting for, basically. On the left, you see the first step, and this is a diamond blade, goes and grinds the surface of the concrete, and it removes the existing transverse tining throughout the pavement. And then the second step on the right, it creates the negative texture by placing grooves longitudinally on the concrete. Now, originally on the 290 project, we had our plan showed for the contractor to place transverse tining temporarily on the project. Again, the problem with this, as I stated earlier, is that creates user error with the rake. Sometimes they push too far down on the rake, and it creates transverse tining that's too deep. And so we were not able to grind those transverse tining up with one pass of diamond grinding. Instead, we had to do two separate passes, so we moved to a three-step process. So again, step number one is the diamond grind that removes the transverse tining, especially the transverse tining that was placed too deep. The second step is the next generation concrete surface grinding, which is a different diamond blade in order to grind that portion up. The third step is the next generation grooving, and that creates the negative texture in a longitudinal format that we want. So prior to the next generation concrete surface, like I said, is the diamond grinding to remove the transverse tining. Now, when we do this, we can place temporary striping to open up immediately after the step one of the three-step process for the diamond grinding. And this allows the contractor to, on one day, remove the tining, place temporary striping, open up to traffic, and then the next night they can come back and do the diamond grinding for the next generation concrete surface. Now, it is a different blade setup, so some contractors, they use different machines for each blade setup. Some contractors, they'll just switch it out during the day, so the next night they can come back with the different blade setup. So to basically mitigate the transverse or error in transverse tining where it goes too deep, what we did on the 290 project is we placed carpet drag in lieu of the transverse tining. So what this did is it allowed us to eliminate the three-step process and move to a two-step process. This saves time and money on the project because you won't have to use multiple machines and or change out the blades, and it still allows us to open up to traffic and after the concrete is placed and prior to the next generation concrete surface. So on 290, when we placed the next generation concrete surface, we had UTSA partnered with TxDOT to monitor the next generation concrete surface after it was placed. The location that they surveyed was on the I-610 North Loop between TC Jester and Ella, and this is the 290 and I-610 project. The data collected was the sound level, skid resistance, and the ride quality. The pre-next generation diamond grinding data was collected in November of 2014. And the post-next generation diamond grinding was March of 2016. This is 3 months after the next generation was placed on that project. And we also did a 6-month data collection on July of 2016. So first, we'll focus on the skid resistance equipment. We used a locked wheel skid trailer with the ASTM, conforms to ASTM E274. That's the trailer that you see on the right. It has a, so after the initial data, the secondary and third data set, we plotted it on the skid number of lane R1. The blue line, what you see, is the pre-next generation diamond grinding, and the skid number averages around 20. The 3-month and 6-month, it increases almost double in this instance, which is huge. So the increase for the skid number on lane R1 is what we are looking for the skid number increase. Lane R2 is a little bit less of an increase, but it still is an increase. Lane L1, again, we have almost double the skid number increase for this, and lane L2 is also the same. So this is something we worried about a little bit with making a uniform land profile for the next generation. We were worried about the skid numbers and how it would be affected by basically having a negative texture instead of a positive texture. So these came out really well, and we were really happy with these results. Next, we'll go to the ride quality. And to perform this test, we had an inertial profile for ride quality. Test procedure for operating inertial profiles and evaluating pavement profiles. We use the TxDOT designation TEX 1001-S. So the IRI data that we received is what you see here. The pre-next generation diamond grinding is in yellow. The 3-month, 6-month, and average is what you see in green. So this is really good data that we received, and it performed better than our expectations. In some instances, it was an increase of over 300%, or a decrease in 300% of the IRI, which is, again, better than our expectations. So the onboard sound intensity equipment that we use to measure the sound is what you see here. We had a standard reference test tires for the tire, and we used a dual microphone system. Now, our analyzer for the dual microphone system actually analyzes one microphone at a time. So you can see the wire that goes down to the right microphone is the microphone that we use to record the sound in this instance. So the OBS I data on this is actually better than what we expected, a lot better than what we expected. In some instances, it reduced by over 5 decibels, and it creates a sound reduction that is not only noticed by us, but it's noticed immediately by the public. Once we implemented the next generation on 290, after the first opening, we received a lot of emails, a lot of phone calls asking, what is this? You know, what are you guys doing? This is really good stuff. How did you reduce the sound so much? And so we had a really good turnout, and public view of this is very high and good. After the 290 project, before the 290 project ends, but next year in 2017, February, we have another project specifically for next generation on I-10 between 610 and Beltway 8. And that project is partially funded by TxDOT and partially funded by a third party has really pushed to get next generation performed on I-10 to reduce the sound and noise that is created from the cars on I-10. And that's it. Are there any questions? Yes.
Do you have the frequency data of those reductions? I know, decibels is one thing, but looking at the frequency as well.
Yes, we have.
I'm sorry, go ahead and repeat the question.
The question was, do we have the frequency levels for the data that we received? And the answer is yes. I didn't include it in my slides, but I can get that information to you afterwards if you like.
I drove it really, really quiet.
Yeah. Yes.
Has this been only used on high-speed facilities, or is it reflecting like an urban arterial?
It can be used on any. The question was, can it be used on urban areas, or is it only used on high-speed areas? So the urban areas has a lower traffic speed, so the noise between the tire pavement interaction is a little bit less than the higher speeds. So right now we're really focusing on the high-speed areas and not the urban areas. But the answer to the question is yes, you can use it on both, absolutely. One more.
Follow-up on that. If it was used in a lower speed facility, not a freeway, it appears that it would be okay for bicycles as well. I don't think those problematic. It doesn't, I don't know. Has anybody looked at that?
So the grooves, the question is, if it's used in an urban area, can bicycles and other, I guess, single passenger vehicles utilize or drive on it? And the answer to that is yes. So the transverse tining that you see, sometimes it's a longitudinal tining. It's basically the same concept as far as the width and the height of the grooves. And as such, yeah, you can use, a bike can ride on top of that, yes. Yes.
You know, with the transverse time, we get the water draining off the pavements from time to time, I guess. Is there any concerns about maybe potential hydroplaning or something?
So there was a little bit of concern about hydroplaning. The question was, is there any concerns about hydroplaning because it's a longitudinal tining or grooving instead of a transverse tining, which the transverse tining allows for drainage. So the longitudinal tining, when you have the tire on the pavement, it allows the water to be pushed out on the longitudinal grooves. Now, there was a little bit of information on skid when there's high volumes of traffic, and it did increase the distance of skid a little bit, but it wasn't significant to where we weren't going to use it on the 290 project. So yes, it did increase the stopping distance slightly, but it wasn't a major increase. Yes?
Do you have information on the quality of the aggregate? Because the durability of these treatments is going to be dependent on the quality of the aggregate.
So the question is, do we have information on the quality of aggregates? Because this might change due to the quality of aggregates. Yes, and so in Houston, we use a lot of limestone, and so it's a little bit harder, or it's harder to grind up. And so that specifically hurt our contractor a little bit on the project. They had to go through a little bit more blades and change that out, which is unexpected. But you're still able to diamond grind those aggregates and create the grooves. Now, the adherence between the aggregate and the cementitious material is very important, because when we create the grooves and we create a uniform land profile on top, you're basically cutting into that aggregate. So you're reducing the surface area between the interaction of the aggregate and the cementitious material. When that happens, it has a slight potential to allow the aggregate to pop up or pop off, which in that case it would create a fin, an unwanted fin. And so, but so far from the experiments that we've done on 290, we haven't seen a lot of that at all. So that's one thing we were worried about, but we didn't see that happen too often on 290. Yes?
Tining and the carpet drag would probably have been done during construction. How long did you wait before you did your first next generation, right?
So the question is, the tining and carpet drag is placed during construction, and how long did we wait until we placed the next generation concrete surface? And what we're doing on 290 is we're waiting till the end of the project on some projects, and we're doing it during phases, intermittent phases on other projects. So the reason why we're waiting towards the end of the project is because a lot of these contractors that are performing this work are not in Texas. They're based outside of Texas. And so to get them to come to Texas, do a certain phase, leave, come back, leave, this is a lot of mobilization. They're taking their equipment and traveling, halfway across countries in some instances to come here, and that increases the price tremendously and very rapidly. So to prevent that increase in price, we said, you know what, let's just do a carpet drag. We'll wait towards the end of the project, and we'll get them to mobilize one time and do various lane closures towards the end of the project to do the next generation. Yes?
Weeks, months?
Yes, months, yes, yes.
How did the contractor handle the disposal of the waste?
So that is an issue that how's the contractor dealt with the disposal of the material? That's an issue we're still working on. I don't have a lot of detail at this moment on that, but that is an issue we are still working on. Yes? I'm sorry, can you repeat that? Pavement, do we have any issues with pavement marking tape on the surfaces? Tape, yes. We have a little bit of issue with tape because when you go to grind up the tape, sometimes it can really affect the machine. It can get caught in the machine. And so what we're trying to do, especially on the next project coming up, which is the I-10 project that starts in February, we'll have to deal with how to remove the tape prior to the diamond grinding. Some of the tape has been in place for a long time, and so we think that we're going to work with the contractor, but we believe we should be able to still diamond grind with that tape in place, but other tape has started to delaminate and pop off, and so that specific tape we'll probably have to remove prior to the diamond grinding for the next generation. One more time? Oh, so the question is, do I recommend using tape on this surface? So, yes, you can use tape on this surface as my recommendation. But again, that we'll have to do a little bit more research on to see how exactly it adheres to the concrete and how it affects between the interaction between the tape and the surface of pavement. Yes?
Do you have an idea on cost, how much this cost over conventional?
So the cost on this is on the 290 project, we're running about 17 million for the whole 13 projects. And it's, some say it's a little bit high, but in retrospect, if we do an overlay, it would have cost double that, about 32 to 34 million dollars to place an overlay to get the same effects and reduction in sound noise.
Well, actually, what I meant was conventional concrete surface treatment versus conventional. What's the difference? How much more does it cost conventional concrete?
So what's the cost difference between the conventional tining, I believe is what you're saying, and the next generation concrete surface? So when you do a conventional tining, it's included in the construction of the pavement. It's something that the contractor does. It's incidental to the pavement item. So the next generation is something after we place the pavement. So it's in addition to the pavement and the payment for the pavement. Yes, completely additional. Yes. So, yeah, so the,
Is that substantial enough to warrant, it seems like not a big difference.
yeah, so the highest decibel levels recorded, I think, by man is around 180, 190, and that's the highest. So when we're looking at a reduction in 5 decibels, that's actually a noticeable, extremely noticeable difference. And that was actually higher than what we expected for the next generation concrete surface, yes. Yes, every decimal that we reduce is yes. So the question was, is there a comparison between longitudinal timing and the next generation grinding, which is also longitudinal? And the answer to that is yes. There was, again, a significant reduction because the whole idea of next generation concrete surface is you're going to have a uniform land profile, and then you're going to have a negative texture, right? And so conventional tining that has a positive texture. And those fins and the texture that is on the pavement, that's what creates the increase in the high noise between the tire pavement interaction. So we did see a significant reduction because we did have a uniform land profile and a negative texture instead of a positive texture, which is really what we're looking for as far as the next generation concrete surface. I'm sorry, say that again? Is there any measurement of obvious signs? OBSI measurements.
He's comparing Grand Avenue Parkway to 290.
Okay.
There's that section that was done from 290 to Tom.
So the question is there any measurements, OBSI measurements, between the longitudinal and the next generation concrete surface? And yeah, so basically on the bridge is where we have the longitudinal concrete, longitudinal tining and grooving on the bridges. And so we have not placed next generation concrete surface on the bridges itself. So for the 290 project and the monitoring of 290, we did just focused on the roadway and not on the bridges. So as far as the data that I have and the data I've received on the 290 project, no, it did not include the comparison between the longitudinal grooving and tining and the next generation.